Hi, my name is Hurley, and I want to thank you for watching my video. Today I'm going to help you learn a little bit about precalculus. The first thing that we're going to dive into is the concept that is known as the function. Okay, one second here. Okay, now a function is a relation in which for every input there is one and only one unique output. Not two, but only one. Okay, and these functions that appear quite often in precalculus, these original unaltered functions we call parent graphs. Okay, and we have five commonly used and commonly manipulated graphs. They are as follows: quadratic function, absolute value function, square root function, cubic function, and cube root function. Now I'm going to pause the video here and take you to the next step. Okay, so I'm going to go ahead and bring up my whiteboard now. Here we go. So now my tiny little picture here is on the side. Okay, and what I'm going to do is maximize this. Move this out of the way and put that up there. Okay, and now I drag my screen here. So I think this is a good setup. All right, here we go. Let's go ahead and get a line. Actually, let me make that line black. Okay, so this I'll call the x-axis. It doesn't look centered. It does not look centered just yet, but I think that's okay for now. It doesn't have to be absolutely perfect. Okay. So the horizontal axis is what we call the x-axis. Let me go ahead and pause this video so I can type it out and you don't have to watch me. Wait, how can I pause the recording? I can't. Okay, there he is. I'm going to pause the recording so you don't have to watch me doing that. Watch me do that. Okay, so now I have it all set up now. So here we are. This is the coordinate plane system that was invented by French mathematician René Descartes. He was born in 1596. Okay, now what we do when we are plotting graphs, we go by the axes. We go out either to the right or to the left, based on if the x from the polynomial or the function is positive. If the x is negative, then obviously we're going to go to the left. Okay. Then we go up or down. Rise is always, I'm sorry, I was about to use the slope intercept form, or how we graph the slope intercept. I was, going into the rise or the run, but it's the opposite when you're graphing. You go on the x-axis, or you run first and then you rise. So anyway, here's what the quadratic function would typically look like. Something like this. I want to make sure that, okay. Now, I'm drawing this by hand, so of course it's not, see, I've already messed up. Not too bad. Anyway, this is something what a what a quadratic function would kind of look like. It won't look exactly like this because number one, I didn't even actually pay attention to like where I placed it. I'm just going by my experience, my memory, and plus I look at this picture here, and this is what we call a parabola. Okay, so again, I didn't graph it perfectly, but this is somewhat what a quadratic function. Whenever like an x is squared, this is the graph what it typically looks like. But that's the original unaltered function. When you start having x minus a number, it shifts to the right. And when you have x plus a number, it shifts to the left. And when you have a constant that's added, like +1, -4, that's when it shifts vertically. So we will learn more about that. Now, again, I'm going to pause the video and get rid of this graph and move on to the next type of function that we often see. Okay, now I've cleared it off. Now I'm going to draw the square root function. Now it's not going to look, it doesn't typically look exactly like this, but see, a hand. Hold on one second, let me pause this. Okay, I'm doing a little bit better now. But yeah, that's something what a square root function, that's what it looks like. Typically, if it's not altered at all, that's the parent function. Again, we have the coordinate system and then, or the coordinate graph, and then the graph itself kind of goes like this. And it starts right here at the y-axis unless it's shifted. This is the parent graph. And then it goes off up to the upper right corner. So now again, I'm going to pause the recording and move on to the next function. Okay, here we go. So now we have the absolute value function. And this is what it looks like, kind of like a V. It can be flipped upside down, like this. And it also can be shifted to the right or the left. It just depends on what type of transformations you have acting upon, or I shouldn't say you have. It depends on what type of transformations are acting upon the original parent function of the function of x is the square root of x. Okay, that's the parent function. So let me go ahead and pause again, and then I will pick up on the next function. Okay, now this is the one that I'm kind of worried about graphing because it's so difficult to do by hand. But anyway, let me go ahead and give it a try. This is what we call the cubic function. Okay. I can just, I think came out a little too far. It kind of looks something like that. Kind of looks something like that. Okay, it's not perfect, but this is the original. This is what the original parent function graph of the cubic root function, what it looks like. Okay, now on to number, is this the last one? Yes, we're going to go on to number 5. It'll be the last one. And again, another one that I'm a little shaky about doing, but I'm going to go ahead and try to draw this cube root. Is that what we're doing here? Yes, the cube root. See, I got it like it's leveling off. It doesn't level off. It's going to constantly be increasing, even if it's just a little. Okay, so that's half. And now the other half is going to be the opposite. Again, it's not perfect, okay? But, oh gosh. It's not perfect, but this is what we call a cube root function. Okay, now again, it depends on what is subtracted from the x or what is added to the x. And it also depends on if the function is the opposite of the parent function. What I mean is if there's a negative in front of the function, then it gets flipped over the x-axis. Okay, and we'll go into more depth about that as I create more videos and explain more to you. So anyway, let me write down each of these 5 functions as a recap, and then we can move on from there. So number 1, we have I can't do 2 different colors on the same line. Okay, so we have the quadratic function. Then we have the square root function. Is that number 2? Well, it doesn't matter. It's not like it's a certain rule, but I'm going I'm following a certain order here. Then we have the absolute value function. I'm sorry, I should be looking to the camera, not staring at the words I'm typing. Absolute value function. And then number 4, we have the square root, right? No, we already did square root. We have the cubic root. No, cubic function. Let me see. Yes, cubic. So, okay, and number 5, we have the cube root function. Now, I think it would help. In fact, I know it would help if I at least, write out each one here in this video, so you don't have to be like, well, why would you create a video and tell us what it's called and not show us what it looks like? Because I would be wondering the same thing. So let me go ahead and do that here. The function of x, is equal to quadratic function x raised to the second power. I don't want to do it like that. I would just simply write the number 2 in the upper right hand corner. I'm going to do a different color, blue. There, that is the function. That's number 1, the function of x squared, okay? A quadratic function. Now, let's go ahead and write the next function, the square root. So this will be f of x, the function of x is equal to, sorry again, not looking in the camera. The function of x is equal to, all right, I'm going to actually draw it out. Draw. Where's the little? Okay, so I have to click whiteboard again. Okay, so I'll write the square root of x. Okay, that is a parent function for number 2. Now, number 3. Let's see, I can change the color to red again. I'll just stick with red and blue, because it's a cute pattern. Then we have the function of x is equal to absolute value. Oh, okay. It's going to look like this. Well, not that long. And now would be a good time to change it to blue so you can see what's going on here. Absolute value of x. And then change it back to red. We will explain, we'll go into depth. I will, make sure that you'll have a better understanding of these topics when it's all said and done. So if it looks like a bunch of gibberish now, don't worry, it'll make sense to you eventually. Next, we have the cubic function. So let me make sure that I write this down correctly. Hold on 1 second. Let me pause the video here because I don't want you staring at the top of my head while I'm trying to find something. Okay, I feel very silly right now because I dismissed exactly what I was thinking. I was thinking in my head, no, it can't be that easy. But yes, it is. It's simply function of x is equal to, let me bring up the drawing tools again. Change it, it's already, I'll change it to red from here. No, stick with blue so you can go to red on the next line. Okay, so the function of x is equal to x raised to the 3rd power. The reason why I had to pause the video, I'm like, hold up, why does cubic function sound so advanced? But I'm thinking it's just x raised to the 3rd power. So when I paused the video, I checked and yep, that's all it is, x raised to the 3rd power. So that's number 4, the cubic function. And finally, we have the cubic root function. And this is what it looks like. The function of x is equal to, okay, you get the square root sign, and I'll change this to 3. And what it is it's, well, yeah, it's of x, but you have to write the tiny little 3 right there in that little hook, and that makes it a cubic root. Here at the top, I'll use, I will use lime green. I'm just trying to use a different color. I was trying to find a light color. Oh, wait. I just put a 3. That's supposed to be a 2. Okay, so there we go. If you don't have a number there in the hook of the square root sign or symbol, it's understood to be a 2, which means that it's squared. So anyway, once again, the quadratic function is f of x is equal to x raised to the second power, or x squared. Number 2, the square root function. Its function of x, or f of x, is equal to the square root of x. You don't have to write the 2 there, but I just wrote it just so you can see it. Number 3, we have the absolute value of the function of the absolute value of x. Okay, it's x inside these two, I think they're called, not braces. I forgot what they're called, but it's on your keyboard. It should be under the backspace button. There's a line that goes vertically up and down, and then there's also a slash underneath it. But that top line, there's the top symbol, there's like this little vertical little sign. You put one on the left and one on the right hand side of the x, and that gives you the meaning absolute value in mathematics. Okay, number 4, we have the function of x is equal to the cube root, or not cube root, but the cubic function. It's just x raised to the third power. Okay, and then the fifth function is the cube root. It's the function of x is equal to, you have the radical sign, and then you put the x under the radical, and obviously you have to write the 3 to designate, to make it clear that this is a cubic root and not a square root. So there we have it, folks. Thanks for watching this video, and if you have any questions, please leave a comment, and I will respond to you. I'm here to help you all because, like you all, I'm a student. I still consider myself a student, even though I'm a teacher as well. So anyway, thanks for watching again, and I will see you in the next video. Okay? Goodbye for now.